Imran Khan was born and raised in Bangladesh. He immigrated to the United States of America with his family in 1994. Mr. Khan studied in West Los Angeles College, where he finished his general education. In the fall of 1999, he started to attend Cal Poly Pomona University. He received his Bachelor and Master of Science in Electrical Engineering. During his employment with Raytheon Science and Airborne System, he worked on the radar modules of F-A-18 and B-2 stealth fighter jet. He worked on transmitter and receiver of satellites during his employment with Boeing Satellite Systems. Currently, he works for NASA's Propulsion Laboratory, where he works on the Mars rover and the Jupiter Orbiter project. Welcome, Mr. Khan, and thank you so much for joining us today.
Good morning. You're very welcome. I hope everybody can hear me. I'm going to start sharing my screen and go into the presentation. Before the presentation starts, there is a short video of the Perseverance rover. Hopefully you will enjoy it. Right, so this presentation is geared towards Mars Perseverance rover, which was launched back in 2021, arrived in February of 2022. Before we sent any rovers, any science instrument to any planet, we sent satellites to collect information about the planet. So in this case, the past Mars mission have followed the water, building on each other's knowledge and discoveries. The satellites collect the information about the planet, the geography of the planet, what is the best place to land, where is the best place to do our experiments. So the first satellite that went to Mars is Mars Odyssey, followed by Mars Express. Then in 2005, Mars Reconnaissance Orbiter. Once we have gathered all the information and understand the planet, we start sending rovers and science instruments. The first rover that went to Mars back in 2003, Mars Exploration Rover. Then it was a science instrument, which is Phoenix Scout in 2007. Science instruments are stationary, they don't move around, they stay in one place and collect information. After Phoenix Scout in 2011, Curiosity rover was sent. Then in 2018, InSight instrument, and the last one is the Mars Perseverance rover in 2020. I think I made a mistake in the beginning. I said it was 2021 when Perseverance rover was when actually it was 2020, November of 2020. So there is plenty of evidence that water flowed on Mars in the past. We know that the planet was wet and habitable. Mars had all the basic building blocks of life, which still exist on the surface today. The left side of the screen, you see what past Mars looked like with a question mark, because we're assuming that's what Mars looked like in the past. The right side of the screen, the right picture, is the present, what Mars looks like as of today. So we want to answer the question, did Mars ever have life? The rover will look for rocks with potential to teach us about the possibility of life in Mars. It will pick the best samples and store them on the surface for potential future return. Actually, it's not potential anymore. We are bringing back samples back to Earth in the near future. Rock samples are key to teaching us about past life. When we bring them back someday, we can find out what's really inside. We can study them in great detail. The Mars 2020 Perseverance mission will look for biosignatures. These are objects, substances, patterns that only life-based processes can prove. Scientists from all around the world selected Jezero crater as the place to land and explore. Jezero crater is home to an ancient delta. There, the rover can access rocks that are up to 4 billion years old. Jezero has rocks and minerals that could only form in water. Some are commonly associated with life on Earth. This makes it a great place to look for signs of habitability and of past life itself. In the video, there's a short simulation. You'll see where the Perseverance rover landed and how it traveled from the from the landing site to the other side to the other areas to collect information. So as it travels from the landing site to these areas, it will collect rocks, soil samples that will have that may have any will store them, and then someday we're going to bring them back to Earth to study them. Perseverance will look like Curiosity rover, which is on the left side of the screen. MSL stands for Mars Science Laboratory. The right side of the picture, what is the Mars 2020 rover looks like. The 2020 rover is equipped with a new set of tools. There are 23 cameras. 9 of them are engineering cameras, 7 of them are science cameras, and the other 7 cameras are entry, descent, and landing cameras. Science instruments study objects, large and small, near and far. The SuperCam can fire a laser, check out a rock from a distance. The Mastcam Z forms a pair of rover eyes. Perseverance is also a good listener. It has a microphone. It can hear and record the sound of Mars. It has a robotic arm to scoop, drill, and study rocks in front of the rover. Like the SuperCam, Sherlock and Pixel are rock analyzers that's in front of the robotic arm. They can study and map area as small as fingernails in great detail to uncover origins, history, and structure of rocks. In its belly and at the core of the mission, the rover carries sample caching system. It's designed to help the rover collect and store pristine rock, Mars rock, and soil samples on the planet's surface. And the simulation here will show you how it drills and then scoops and then stores rock or soil samples under the belly of the rover. So once it collects all these rock or soil samples, it will move on to the next site to explore or collect rock and soil samples. So the rover has a new tool to convert carbon dioxide in Mars atmosphere into oxygen. It's called MOXIE. Um, so the MOXIE instrument uses a electrochemical process where it extracts the oxygen molecule. Actually, it um, takes breakdowns the carbon dioxide. So carbon is made of CO2, so it separates the carbon and the oxygen, and releases the oxygen into the atmosphere. So our the purpose of this instrument is to generate oxygen. The MOXIE instrument can be used as a backpack for the astronauts when they arrived in Mars. Um, Mars atmosphere consists of 94.5% carbon dioxide. So there are plenty of carbon dioxide exist on Mars atmosphere. So in this instrument can convert that carbon dioxide into oxygen so that our astronauts can breathe. They don't have to carry an oxygen tank. They can use the MOXIE instrument can do that for them, and they can they can travel further without worrying about running out of oxygen. And as I speak, this MOXIE instrument is doing that job right now. It is producing oxygen in Mars. Perseverance rover carried a passenger. It's a small camera. This helicopter is a technology demonstration experiment. So this is so far we did 8 flights in Mars. This is the first time we were able to fly a robotic plane in an alien planet. The helicopter is mounted under the belly of the rover. And like I said, so far it did 8 flights. Now that we know the helicopter can fly in Mars, we can build more drones or something like another helicopter which can go further. The the rovers have obstacles. They have rocks to climb. They have mountains to climb. The roads are really um, 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 hard to travel on. So with the help of helicopter, they don't have that obstacle, and they can fly around and cover more grounds to the other side of the planet, and we can collect more information. Also, the helicopter acts as a scout for the rover. It tells the rover if there is a obstacle in the path ahead, and the rover and the helicopter communicates back to each other via receiver and transmitter that is on the rover and the helicopter. So under the belly of the rover, there is another tool called BRIMFAX. The BRIMFAX uses radar to see geological features such as sand, rock, or ice. Perseverance rover was launched back in July 30th of 2020. It arrived in February 18th of 2021. It takes about 8 months to arrive in Mars. The spacecraft travels about 354 million miles and approaches Mars at 13,000 miles per hour. Once the spacecraft enters Mars' atmosphere, the spacecraft starts taking picture of the ground, and it compares those pictures to the orbital map inside the onboard computer. Once the picture matches, the spacecraft deploys the sky crane, and the sky crane deploys the rover onto the ground. So the rover uses a descent stage to slow down and hover just before landing. The rover uses radar to measure its speed and altitude. The rover touches down at about 2 miles per hour. The primary mission is about 1 year, which is equal to about 2 Earth years. Now, once the primary mission is completed, then the rover will have extra mission. They have another additional mission that the rover will carry on and do and explore the Mars surface until the rover dies. The instruments are built to withstand the Mars atmosphere, the sandstorm. So the rover has we believe the rover can last about as a minimum 10 years of that, because the Curiosity rover lasted almost 11 years. So Mars 2020 is the next natural step in Mars exploration. The mission will explore a diverse landing site, seek sign of ancient life, collect rock and soil samples for possible return to Earth, and pave the way for human exploration. I have 2 more slides to show before I start taking questions. So on the screen, you'll see it says Mars sample return. This is the project that's currently going on, and I'm also working on. This is the Perseverance rover that is collecting all the rock and soil samples. And then we have another mission called Sample Retrieval Lander Mission, where another lander will go and collect all these samples, bring this sample back to this another stationary instrument. After that, we have another mission, which is Earth Return Orbiter mission, where a return orbiter will go to Mars and it will orbit the Mars. This instrument here will shoot the samples into the orbit, Mars orbit, and then this orbiter will collect those samples and then bring it back to Earth. And this is what the return orbiter looks like. That will bring those samples back to Earth. For the presentation I have, I am open to take any questions.
Mr. Khan, we have a few questions that popped up in the chat box. So first of all, somebody wants to know, how will the rover come back to Earth?
Rover does not come back to Earth. None of the rovers, none of the science instruments come back to Earth. It stays in Mars.
Okay, and another person wants to know more about what you do for NASA.
So I work on the electronic components of the rovers and any science instrument that goes to any other planets. I determine if the electronics components can withstand the space environment.
Okay, so we're getting the questions pretty quickly now. So how does a spaceship move so fast?
Well, it has an engine, just like a car engine. But the engine is much more faster than a car. Just like the rocket, it travels, it uses that engine to travel in space.
Okay, and somebody wants to know, where does the power for the rover come from?
It's from the battery. The battery charges the are charged via solar panels, and the solar panels powers the battery.
Okay, I guess kind of related to how the rovers operate. Somebody wants to know, will there one day be a way for the rovers to repair themselves if they become damaged?
Everything is possible. Yes, it is possible. The robots can fix themselves.
Okay, and this was kind of an interesting one. How would it help us if we found life on Mars? What happens next if we find life on Mars?
I don't know how to answer that question. I'm an engineer. I just strictly work on the rover. I have That's a question for a geologist or a planetary scientist that can answer that question.
Okay, we're going to change lanes and go back to rover questions. So, what
Yeah.
is the rover made of, and how long does it take to make a rover?
So the rover, it's it's a very general question. The outer case is made out of aluminum. The wheels are made of advanced aluminum. The electronic components that go inside the rover are protected by aluminum. The electronics components are made of various materials. I mean, the list is very big. There's no, each component is different. They are made of with various type of materials. But in the outer shell, the rover body, the rover wheels that are made of aluminum.
Okay, thank you for that. And somebody wants to know more about you. What interested you to pursue a career in this?
Uh, I would say Star Trek. I used to watch Star Trek a lot when I was a little boy. Um, I would imagine I remember I was imagining that I'm in a spaceship traveling from one planet to another, try to study that planet. And then also motivation from my parents. They motivated me. They saw me that I am good in math and science, so they motivated me to pursue engineering.
Okay, so we have a question that you already covered about how the rover gets its energy. We learned that was from battery power. Somebody else thanks you for the very interesting presentation and wants to know the power source for Perseverance. Is it exclusively solar, or is there another source like nuclear energy involved?
There is another battery power. It's um, another battery power that I can't talk about. And but the most of the primary battery is powered by the solar panel.
Okay, I'm not sure if you are at liberty to disclose how much money it costs to make a rover or if you are even aware of this.
No, I am not. They don't tell us how much does it cost. That's strictly a uh, sensitive information that they don't want to tell us as an engineer.
Okay, and how do samples make their way back if the rover never returns?
Well, I just showed two slides where we are sending another lander to collect those samples, and then we're going to build a return orbiter that will bring those samples back to Earth. The samples will be collected by a lander, by another rover, and another science. And that rover will take those samples to another uh, instrument, and that instrument will shoot the samples into Mars orbit, and the return orbiter will catch those um, samples and then bring it back to Earth. So we're looking at 2030 when we'll have the samples back in Earth.
Okay, thank you so much for that. And Mr. Khan, we actually have so much interest in what you do that there are some fast and furious typers out there. So, in the interest of staying within the time and also not being too redundant, I'm going to kind of pick a couple questions for you
So
that we haven't covered yet. So, somebody wants to know what the timeline is looking like in terms of sending humans to Mars.
That's unknown. We just solved the oxygen problem. Now that we can generate oxygen in Mars, we have a couple more obstacles to overcome. The other obstacle is water. How do we generate water? We need to have enough water, not only on the in Mars, but for the travel. It takes about 8 months for the travel. But the most important issue is um, traveling 8 months in a small spacecraft. The human psychology, we need to figure that out, how human behaves, or how psychologically, how they can last in the spacecraft. So there are so many obstacles that we need to overcome. That question, we don't know right now when we can send human beings to Mars. Hopefully soon, but we need to figure out the water, the food. Um, can human last 8 months in a small spacecraft without TV, without YouTube, without Facebook, any interaction to another human being? So those uh, puzzles need to be solved before we can say yes, we're ready to go.
Okay, thank you so much for that. And we have some maintenance related questions. So, how are things like solar panels kept clean? And how are electrical systems kept safe from things like extreme temperatures and storms?
So the solar panels it's a small solar panel. It's not a large smart solar panel. It can fall down when there's a sandstorm. The electronic components, the boxes itself are sealed, so nothing can go inside. Yes, even after all those, sand can go all over the place. Um, there is no way to, there is no self-maintenance. It just, everything is sealed so that nothing can go inside. Now remember, Mars is very cold at night. So at night, the heater turns on and keeps the sensitive components warm. Um, but other than that, during the day, the temperature doesn't go as high as like Earth because Mars is further away from the sun. But there are no self-maintenance for the rover.
Okay, thank you so much. We have a kind of interesting question on a topic we haven't touched yet, or we only touched briefly. But if somebody is interested in pursuing a career in space engineering, or working for NASA in the future, do you have any words of advice or any advice on what path a kid can take?
Yes, I mean, if it depends on where that person is right now. I mean, from high school, you need to be good at math, science. Obviously, that's what the main. Those are the subjects that required for an engineering career. And as you go into higher education, such as community college or four-year university, you need to be taking classes based on your career choice. Now, remember, engineering is it's a broad subject. There are mechanical engineering, there are electrical engineering, there is structural engineering, there is robotic engineering, there is aerospace engineering. So there's a variety of careers in engineering. So it depends on what you want to pursue. Uh, right now, any engineering field related to the space is in high demand, and I think it will be for the near future, like robotics, aerospace, mechanical engineering, electrical engineering. So um, it depends on what you want to do. Um, but from the beginning, from high school, you need to be prepared for um, prepare and make sure you understand the basic concept of math, algebra, geography, because when you go into higher education, they just get harder and harder. But if your foundation is strong, then you should not have a problem. But I would say from high school, you need to practice and study more. in mathematics and science, so that when you go into higher education, you don't have any issues with higher math and science.
Hey, thank you so much for that insight, Mr. Khan. And just in the interest of respecting your time, how many more questions do you think we can get through?
I'm here. I can another 10, 15 minutes. I can be here, so we can continue to.
Okay, let me see. Let me see. Which ones are topics that we haven't discussed yet, or things that kind of stick out a little. So, will rovers be sent to planets other than Mars one day?
Yes, we have a project going on right now, which is we're sending an orbiter to one of the moon of Jupiter, planet Jupiter called Europa. Planet Jupiter has 53 moons that we so far discovered, and one of the moon called Europa. And what we found is the outer crust of Europa is made out of ice. So we believe that if there is ice, there must be water inside that moon, and we are sending a satellite to collect information. Once we collect information, if we can land a rover or a science instrument, yes, then we can send a rover and a science instrument. But if we believe that we cannot land a rover or any science instrument, then we don't send anything. But we wanted to understand the planet before we send any rovers or science instrument in the ground. So yes, we are going to Neptune. We're sending a satellite to planet Neptune to understand the planet. Uh, if we can land, yes, we will send rovers to that planet and we will land. But if we cannot, then there's no point sending anything to that planet.
Okay, I'm getting a couple questions that I have a feeling might be out of your wheelhouse. Feel free to say so if they are. If you have an opinion about them, feel free to chime in. But they're mostly questions related to what happens if, Mars is a territory. Is there going to be a fight over it? Are there going to, what happens if there's hostile creatures on Mars? And how close to life do you think sci-fi movies and TV programs are? How close are they to real life?
Uh, I don't know if there are any hostile creatures in Mars that will we will have a conflict with. I mean, from the surface itself, we haven't found anything. We sent the rovers, nothing has happened yet. But that's I'm not saying that it will never happen. Maybe those creatures haven't um, um, uh, we haven't seen them, we haven't found them, but so far we don't have any issue. We're not doing anything to disturb anything in that planet. Uh, we're just exploring. We're not by any means being destructive to that planet. So I don't know if we will ever have conflict with anyone. But right now it's just an exploration project. It's not nothing else. Um, in regards to the sci-fi movie and whatnot, I have no idea how close to this. I mean, all I can tell you that it is, um, it's very hard to build a rover and then sending it to Mars or any planet. Takes a lot of time, a lot of energy, lots of people dedicate the time to do this project. So um, um, how close to it? I mean, it's not as I'm not gonna say it's really close to the sci-fi movie, but it's not. Uh, we are quite a bit far away from that sci-fi movie.
All right, thank you so much for that. A very complete answer for something that's so open-ended. We have a question that might have a more directed answer right now. Does the decrease in mass in Mars's atmosphere affect the rovers?
No, so far it has not. We haven't seen it. answer the question. But rovers are still functioning. So,
Okay, and then some questions want to know if we have planets where there is no surface. This person gives the example being Jupiter as a gas planet, and there's no surface area to land. What happens in terms of explorations of planets with no surface area?
we just explore from the space. We only land on the planet itself. If there is no surface, then why would we land? We just orbit the planet and try to understand and move on.
Okay, and if the rovers don't come back, is there a reason? Is there a way that rovers can actually be brought back? Because from our understanding, they stay on Mars, but is there a way to bring them back if we want to go that route?
Sure, there is always a way to bring them back, but that's going to be a lot of money. Of course, we have to build a rocket, send some people over there to bring or build a rocket, land the rocket into Mars, and then put the rover inside the rocket, shoot the rocket from there, bring it back to Earth. I mean, yes, it is possible, and maybe in the future we will do that, but as of today, that's not in our plan because it will be very expensive. And not only that, we need people to go to Mars first. So I don't see right now there's no way to bring the rover back. We can build more rovers. I'm pretty much sure that we can build more rovers with the money that will cost to bring that particular rover back.
I see. So we have to prioritize how precious funding goes, and it might just not be cost effective.
Right.
Okay. Somebody wants to know if there are any precious stones found on Mars, or if there's any other interesting things that the rover has found on Mars.
No, so far we haven't found any precious materials or anything. We are right now just looking for that water. We're trying to find what happened to the water. Where did it go?
Okay, we have a question where somebody wants to know, will oxygen affect the samples once they come back to Earth?
Well, the samples will be vacuum sealed inside a tube, so it will not be exposed to the oxygen. When we take it out from the sealed tube, it will be inside a controlled lab. So we will make sure that oxygen does not uh, affect, or the samples are not exposed to oxygen.
Okay, thank you so much for that. And do you think that we should just take like another question or two, or how are you feeling over there?
Maybe one or two more questions, and then we'll end.
Okay, I think that you covered that we have not brought anything, we have not uncovered anything in terms of precious stones or anything interesting from Mars. So I take it that also means that we have not brought anything that contains life back from Mars. Is that correct?
That is correct.
Okay, and then let's take one more. I'll try to make it one that we haven't touched on yet. Mm, There are just so many people who are really excited about what you're doing. So this is fantastic. Let's see. Okay, somebody wants to know that is there a chance that we would be able to use rovers in a way that they become weaponized in the future?
That's not the intention. We don't have any intention, plans, or anything to weaponize anyone.
Okay, I'm sorry, I misunderstood the previous person's question. They want to know if we have imported anything from Earth to Mars.
No, we have, well, we imported rover.
Or exported, I guess that would be the case. If we brought anything from Earth to Mars, not the other way around.
No, we have not.
Okay. And I think that just about wraps it up.
Okay.
Again, I want to thank you so much for joining us today, Mr. Khan. We've all learned so much about what you do, and I can tell there are a lot of people out there excited about your job and really excited about what NASA does and about what JPL does.
If they need more information, they could just Google NASA Mars Red Planet in Google search. There's so much information in the website, so they can learn about what we're doing in JPL. They can learn about what NASA is doing in the Red Planet.
And I know that we're in pandemic times and we're not currently doing this, but in the past, JPL did conduct open houses every now and then where the public can take a look at the facilities. Is that correct?
That is correct. It is slowly starting back up. We are, I think, June, in the coming months, we're going to open on a limited basis for public to come and visit us. But it is open very soon. We will go back to that public event. I just sent a link to you. You can maybe want to broadcast. That's a link to the Mars planet, to what we're doing in Mars.
Okay, wonderful. We'll put that. We'll make sure that the attendees get access to this link that you just sent. And then, yeah, so I think that is about it. We've covered a lot. Thank you so much, everybody, for joining us today. We hope you enjoy today's presentation, Careers in STEAM, NASA's Journey to Mars. Look for more information about our upcoming virtual programs on our website, lacountylibrary.org. And if you haven't yet, we invite you to sign up for our Summer Discovery Program happening now through August 14th, where you can enter opportunity drawings for reading books and completing challenges. So stay safe, everybody, and have a wonderful rest of your day.
Bye. Thank you for having me.